Good morning, everyone. This is Shauna, and I'm coming to you in this video with some homework help for section 9.4, testing the difference between two proportions. We're also going to have confidence intervals in this section, but remember, since we're working with two groups, anytime we're working with two groups, no matter what the parameter is, we're going to be using the calculator for that. And if we have a hypothesis test, we're going to be doing p-values. So just by way of introduction to the slides, I'm not going through the whole group of slides, but this is just for your own sake. This is the formula, okay, for the test statistic for a two proportion test. You're not required to use it. You're not required to know it, but she does want you to be familiar with some of the notation because some of it reappears in your confidence interval and in your hypothesis. So she wants you to be aware of what it is. P1 hat, we know, is the sample proportion for the first group. P2 hat is the sample proportion for the second group. Then we have the population proportions, P1 and P2. This P bar and Q bar, these are pooled proportions, which we're not going to get into, but you can see the formulas on the screen. P bar is x1 plus x2 over n1 plus n2, and so forth. Q bar is the complement, and then n1 and n2 are the sample sizes. This is the procedure for doing a hypothesis test with two proportions on your calculator. We'll go over that. You'll find it here. You'll also find it in a separate page on Canvas, okay? Remember, we can have summary data like she does in this example, or we can have, in some cases, we can have actual values. Usually if you have proportions, you'll have the summary statistics, but if you have means or variances, you might have either one, okay? So let's look now at the homework question. The first part of the homework is just some basic arithmetic, just so you can remember how to find p hat and q hat, because again, we need that for the formulas themselves. You need to know that in order to be able to perform the rest of the hypothesis test. So number one, find the proportions p hat and q hat for each. So we know, for example here, n is 48 and x is 34. Okay, so here, if this is 1a, okay, 1a, n is 48, x is 34, okay? We're looking for p hat and q hat. So here, p hat is going to be x over n, okay? So this is equal to 34 over 48. So you get 34 divided by 48. We've done this a lot of times already. So when you pull it up, we're going to pull up the calculator. This is 34, and this is 48. It's 0.7083. And our Q hat is just the complement of that. So it's 1 minus the answer you see on the screen. Whoops. My apologies. Let me see if I can fix this. This is 1 minus. Go enter. There it is. So your P hat is 0.7083, and then you have 0.2917. So here, this is equal to 0.7083, which we can round to 70.83%. And Q hat here is 1 minus P hat. So we know this is 1 minus P. And we know this is a P hat here. So we're dealing with this is equal to 1 minus 0.7083. Okay. And that's equal to, if we go back to the calculator, that's equal to 0.2917. Okay. So here we get this is equal to 2917, which is equal to about 29.17%. Okay. That's how those work in number 1. So, I mean, those are things that we've done before. You just do x over n for each one and then take the complement. Okay. Number 2, find each x given p hat. So here you have 0.16 and p is 0.16 and n is 100. We know, for example, that here you're going to have 2a Let's do 2a down here. 2a, right? We know that in this case, we know that p hat is 16. We know that n is 100. Now, from the formula that you see on the screen above, if you think of just cross multiplying here, x, which is what we want to know, x is going to equal p hat times n. Okay, so all you need to do is multiply p hat by n to get x. And again, this is just reminding you of where some of these things come from, because we will be needing them when we do single proportions back later during the final, but you're also going to see it, as I said, in the question. So x here is going to equal 0.16 times 100. And this is going to give you 16. Okay. This is going to give you 16. That's your x. Okay. Now, remember, if they give you a percent, like they do in 2C right here, you have to convert that percentage to a decimal before you multiply, okay? So 6% is 0.06. Times 800, okay? But that's how you find those. I will show you one of the hypothesis testing questions. Or the confidence. Now, let me show you number 3, because number 3, and some of these have both, so be careful. Let me do something here. I'm going to stop sharing my screen for a moment. And I'm going to pull up something here for us that we're going to need to help us before I get too far into this. Let me drop my view. Most of the questions in this lesson have both things attached, the confidence interval and the hypothesis test. Okay, so I want you to be aware of it when you're doing the questions. All right. Let me find the problem that I want to find. Okay, here we go. This is the problem that I wanted. So here we are. And I'll take you through it as well. But here we go with what I wanted to show you. So here is the problem. A lecture, ignore the number. The number came from a different set of homework. But this is problem 3 on your homework assignment, okay? A survey found that 83% of the men questioned preferred computer-assisted instruction to lecture, and 75% of the women preferred computer-assisted instruction to lecture. Okay. There were 100 randomly selected participants in each sample. Now, notice what it says here. It says at alpha equals 0.05, test the claim. That's a hypothesis test, that there is no difference in the proportion of men and the proportion of women who favor computer-assisted instruction over lecture. Okay. So the first part is to do the 5-step hypothesis test using the p-value method. Okay. So here we have our parameter, is proportion, we know that. We have our men, and she wrote it out for you, okay? Because you're going to need this X, this is your X, to get your proportion, okay? So we have the percentages, we have the numbers here, right? And we have it for the women as well. So here's your hypothesis test, all right? So we're going to do a proportion, P, and here's my steps. It said, test the claim, if we go back, it said, test the claim that there is no difference in the proportion of men and the proportion of women, okay? So if you remember, here's how it looks. If you remember, we have this. We're gonna go for this is problem 3. And we're gonna do the hypothesis test first. Okay. Hypothesis test. So here we're gonna have parameter. This is all set up. Okay. Parameter is gonna be population proportion. And actually it's the difference in population proportion, but it's population proportion P. All right. Then we're going to see what your claim is. So your claim here is that there is no difference. So the proportion 1 and this is HO. Proportion 1, because there's no difference, that means they're the same. Proportion 1 is equal to proportion 2. That's my claim. Now, once I get my claim, then I look at my method, use the p-value approach. And my givens. My given information, okay? So I'm gonna have given information for the men. And I know that for the men, we have 183%. And for the women, we have the same 100, and they're 75%. Okay. We're doing this at alpha equals 0.05. So when you do it, we have um, so you're given information for the men here. We know that we have P hat is 83%. And now you see the reason for the exercise, and N is 100. Now remember, you don't have X, but you can get it. So here, when you do the women's information, the women had this is T hat is 75% and N is 100. Okay, there's my data. Now, you're going to go through and you're going to do your hypothesis testing steps. So step 1 is we write our hypotheses, okay? So we're going to say HO, and what I will do is put my hats on my P's. This is P hat, this is P hat. Remember, these P's are not hats, the ones that are in the null and the alternative hypothesis. This is going to be P of the men, if you will, 1 is equal to P2. And remember, that was my claim. P1 is equal to P2. This is my claim. And then this data, H1, is going to be P1 is not equal to P2. So P1 is not equal to P2. We know that this is a two-tailed test. And those are my pieces, right? My claim, my direction, my statistical equivalent is just going to be the same thing. Because it's just equals. So now, and remember up here in terms of my given, my alpha is 0.05, okay? Now, everything else, you're gonna put in the calculator and get off the calculator pretty much. So once you set this up, the hypothesis test is actually pretty straightforward, especially given all the work that we've been doing. So step 2, remember, since this is a p-value, step 2 here is my test statistic. So I'm going to write that just to remind us. This is step 2 at this point is my test statistic from the calculator. I'll show you how to get that in a minute. Step 3 up here step 3 is going to be my p-value, also from the calculator. Okay, so step 3, we're doing the p-value. From the calculator. Okay, just to remind you of that. Now, I'm going to go over here and go to the calculator and show you that. So I'm going to stop sharing this screen, slide over here. Now, to get our calculator commands, we're going to go to stats. We're going to go to tests, and we're going to look for something called a 2-prop z-test. 2-prop z-test means 2-proportion z hypothesis test. And that's what we want. So we're going to hit 2-prop z-test. We're going to hit 2-prop z-test. And we're going to hit enter. Now, X bar 1 and N1. X bar, we're going to say was the males. So that's 83, X1, I should say, 83 out of 100. And your women were 75 out of another 100. P1 not equal to P2, and we're going to calculate that. Now, don't get confused by all the P's on your screen, okay? P1 not equal to P2, that's your alternative hypothesis. That's your H1, okay? Z 1.3888, that's your test statistic, okay? This is your test statistic. The next P underneath it is your p-value, okay? So your test statistic here is 1.3889. 3888, sorry, 3888, because there's a 3 behind it. So it's 1.3888. So we're going to have our test statistic as Z is equal to 1.3888, okay? Now your p-value, as I mentioned, comes from the calculator. So your p-value will be, let's look, your p-value from the calculator. It's 0.1649. 0.1649 is my p's. Okay. So we're going to have 0.1649. Okay, so there's my p-value. Now, step 4 is the decision rule. So we're going to make our decision. And remember, we're making our decision by means of comparing P to alpha. So step 4 here is going to make our decision to reject HO or do not reject HO. Okay. Now, if you compare your p-value, here's your p-value to your alpha region. Okay. Your p-value was 0.1649. Your alpha region is 0.05. How does your P compare to alpha? Well, your p-value here is larger than alpha. Now, when P is larger than alpha, we do not reject the null hypothesis. It's when P is low, when P is smaller, that we reject the null. So we do not reject the null hypothesis here. And so we say, you can write your justification. You can say, do not reject HO because p-value is greater than my alpha. Okay, that's what you say. Now, what can you say about the claim? Remember, we have to make a summary statement for the end of my hypothesis. So step 5 here is to say that so because my claim was HO and I did not reject it, I can say there is not enough evidence to, and remember my claim was HO, to reject the claim. Now, that's your hypothesis test for this question. All right. I want to show you something else. There's not enough evidence to reject the claim. Don't forget to underline the words is not and reject. Okay. Though that's my hypothesis test. Now it also asked me to do a confidence interval. Okay. That doesn't require too much more work, but your hypothesis test needs to show these things here. Okay. So let me start something at this point. There's my numbers. Okay. And scroll down. Okay, right here. Claim is HO, do not reject it. Here's your flow chart. There is not enough evidence to reject the claim. Okay. Now, the next thing she wanted us to do was a confidence interval. And this is something that I haven't shown you too much of. All you're going to do here is we're going to go and she wants the confidence interval. So we're going to start a new whiteboard over here. When you're doing a confidence interval, this is problem 3 still, but this is the confidence interval associated with problem 3, okay? So what we're going to write is we're going to write our information down. I mean, yeah, we have the same information, but I need to check to see what the level was. So let me look back at her notes here. We're looking for find the 95% confidence interval for the difference of the two proportions. So what we're doing is we're going to say the difference of the two proportions. So this is a confidence interval. This is a confidence interval for two proportions. And so this is going to involve the command to prop the int on the calculator, okay? Which means we're going to need to bring forward those elements of our data. So for the men, to remind you, for the men, we had n equal to 100 and x1, because this was group 1, we had 83. Okay. And then for the women, for the women, we have N2 is equal to 100, and X2 is 75. Okay, so those are your things here. Now, all you need to do is you're going to show the interval on your calculator, but something interesting happens. And if you watched my other video on means, you saw it happen there as well. But let me show you here, new share. Let's go to the calculator. So we have this, okay? We're gonna go to stats. We're gonna go to tests. This time, everything, by the way, on this menu, everything that ends in test is a hypothesis test. Everything that ends in interval or INT is a confidence interval. We want the two proportion, because we're testing the difference between two proportions Z interval. What we want. We already have our data, and the default is usually 95, unless you've been doing confidence intervals, and sometimes there's changes. But if you do a hypothesis test, you're set up to do the confidence interval automatically. So just calculate that. Okay, now look at the top and write this number down. So I'm going to write it down on my piece of paper next to me. So I have negative 0.0324, and the upper limit is 0.19235. Now, these are proportions. Okay. You'd really rather that this not be, if they're both negative, you can get rid of that by flipping the data around, okay? But here we can't do that. We do something different. What we do is, she doesn't care about proportion differences that are less than 0. Why? Because this is a probability, okay? So you'd write the interval just like this, negative 0.0324 is less than the difference in proportion. But if we want probabilities, she's gonna suggest that if you get this left end to be 0, I mean, this is left end initially to be negative, that you make it 0 because it's not supposed to be, okay? So you're gonna write this interval, and then you're going to change this. So it's gonna look like this, okay? We're gonna have, so our original interval, we drew our interval, and our original interval is your original interval is going to be negative 0.0324 and 0.19235. Okay, or 24 if you want to make, we'll fix that in a second. But now, if these are both positive, then you go on and make them percentages and you're on your merry way. However, we need to resolve the problem of the negative left endpoint. So what we're going to do, as I said, if they were both negative, we would turn the groups around. But being that it's only one endpoint, what we're going to do is we're going to take advantage of the fact that probabilities cannot be negative. So she's going to edit the interval since and you're going to report the following. So you're going to say that your interval is from 0 to 0.1924. Okay. Now that's your decimal. Okay. But she also, remember, when you have percentages, you convert it to a percent. So this goes from 0%, 0% to 19.24%. Okay, and that's what we're going to say. Let me check a couple of things here. That's her answer on the answer key. I'm also going to check something else. So we're going to look at the okay. This is our answer key. So if you look at the answer key here, she has 0.1924. Okay. So that's how that works out for that. All right. So I hope that this brief video has helped you. And I will be tracking your messages and your email. So I'm going to see you in my next video. Hope it's been helpful, and I'll see you soon. Bye for now.